streaming for our first session on grinding LeetCode. As you might not be knowing that my LeetCode skill is as poor as I am. So I'll be starting working on my LeetCode skill, and for that I am following LeetCode IO road map. So this guy has done such a great work. So I'm gonna select a neat code all. So whatever questions he has attempted, so he has created that basically list, and I'll try to be consistent. If you guys want to follow me, I don't think so. There's a LeetCode some for LeetCode follow thing is present or not, but okay, you guys can follow me. You guys can follow me. Perfect. Let's see how I progresses and how consistent I am on this LeetCode journey. I have already started the timer for 1 hour, and I'll be grinding LeetCode 1 hour daily, and I'll see how I'll be at the end of a month, at the end of a year, quarter, whatever. Okay, so without wasting a time, let's start. Let me just check if we are live or not. All right. So I have verified we are live finally. Let's go to LeetCode. So I have already finished 3 of these questions before I thought I'm gonna start this live stream. So I'll be working on this one. So the strategy I'm gonna follow is that I'll be working on the LeetCode, and then the solution I'll be pasting on the LeetCode. I am very poor. The language I'm choosing is Python because I'm also working on my machine learning skills, and for that I need Python. Alright, give 2 strings SNT return true if the 2 strings are anagrams of each other, otherwise return false. I know anagrams is kind of what is anagram? So looks like anagram is something which has some common words. So I'll go to Gemini. I will ask, what is an anagram? Okay, race car race, or this is not an anagram. Perfect. So basically the logic which I am thinking is that it should contain all the letters the number of times it is present. So if there is a word, then first the length should be same. That should be the one condition. So if a length is not same, then it will obviously not be an anagram. And then the number of letters that we are counting should be same. So I can use a hash map to store the number of letters, number of each letters occurring. So for that, for example, if length of s is not equal to length of t, then return false. Return false. Else what I have to do? Else else मैं कैसे करूँ? How should I take this. It's going to be, I have to store the hash map. So one time I have to do loop, and then the easiest way. So the easiest way should be, I mean, if I'm looping 2 times, then it's kind of an log n, right? I'm looping 2 times. So I loop for the s, and then I loop for t using s. So basically, let's say hash map is equals to, how to create hash set, how to create hash in Python, how to create a hash map in Python. I forgot. Oh, it's dict. It's dict. I was using set. It's dict. Now once this is done, I have to for e means element, for element in s, for element in s, मैं भूल गया भाई, कैसे, okay. I have to create a dictionary using a string by looping it. Yeah. Right, so he did that in this way. If e is in, if e in dict, no, if e in hash map, then accessing hash map like this, hash map e is equals to plus equal to 1, else halsh else hash underscore map e is equals to 1. We have the dict ready. Now oh my god, I don't know now. So basically now I'm gonna use ChatGPT, Gemini. So I will write it. I was solving this question and my approach was that I will be creating a dictionary using the first string s and then validating by looping it again on t, and checking if the number of elements and the number of times the elements present in t is present in s in the hash map or not. I have my solution as well, but I have not completed that, so I need your help in finishing that. All right, let's see. Your logic is spot on. Yes, since you have already built the frequency map, the hash map for string s, the next phase is to consume those count using string I. If t is truly an anagram, every character in t should be able to cancel out a character you stored s, completing your code. Phase 2 validating against t. If character is not in os, we ran out of the character, e is not having this. What is the how can I say speed of the L? What is the O of n? So what is the O of n of this function or this algorithm or the solution which I have written, and is there any better way to write the solution or not? You have implemented the optimal way is actually the optimal way to solve this problem in terms of the complexity. The big O complexity is O(n), where n is the length of the string. Time complexity O(n). You iterate through string s once to build the map, and then through string t. Even though there are two loops, they are not nested, so the operations are stay linear. Okay, so it's a good one. Is there, but better usually depend on whether you want the code to be shorter or faster. The Pythonic way, if you aren't required to write the loop manually for an interview or assignments, Python counter does exactly the same what your code does in a single line. It creates a frequency map and compares them automatically. So basically, okay, so there is a use of the Python collection counter. So basically count from collections. Okay. So if you aren't required to write the loop manually for an interview or an assignment, Python counter does exactly the same. Okay, it creates a string bool return counter s is equals to counter 10. Okay, so it if you are strictly forbidden from using hashmap extra memory, you could short both the strings. If they are anagram, then short version will be identical. Use no extra space over one. If sorted in place, slower O log n, because it's stored. Oh God, I'm getting distracted. Okay, I got solution. What is the solution? Valid anagram. Okay, before attempting the problem, you should be comfortable with hash map, using dictionary or hash map tables to count the character frequency, sorting strings or arrays to compare the elements in a consistent order, using fixed size arrays as an efficient alternative to hash map for limited character sets. Okay, right, that approach I can take. That every question, if I have to create a hash map, I can validate in front whether I can create it with a fixed number of in some way. If I can create the hash map with the decided number of elements I'm gonna store in it, so that's a good way. I will check every time. Sorting, and if two strings are anagrams, they must contain exactly the same character with the same frequency. By sorting both the strings, all the character will be arranged in a consistent order. If two sorted things are identical, then every character and its count match, which means, okay, if the length of the two string differ, return false immediately, which we did. We were knowing it. Cannot be sort both the strings, compare if the sorted version of the strings are true. If they want, oh my God, this was so easy logic. By time complexity, time and space complexity, time complexity n log n and m log n, space complexity O, but depending upon the sorting algorithm. So where n is, okay, hash map. So basically first method is using sorting. If two strings are anagrams, they must use the same character with the same frequency. Instead of sorting, we can count how many times each character appears in both the strings. By using the two hash maps, we track the frequency of every character in each strings. If both frequency maps match exactly, then the string contains the same characters with same frequency, meaning they are anagrams. If the two strings have different lengths, return false. Different return false, create two hash map to store character frequency for each string. Iterate both the strings at the same time. Increase the character count for SI in the first map. Increase the count at TI in the second map. After building both the maps, then compare. Oh wow, this is an efficient way. Instead of me going over first one and then creating another loop for the second one, I can just have one loop and I can set this thing. So how he did this is really good. This is really good solution. This is a really good solution. Is anagram okay? Is anagram self S? So length is false. Okay, so counts T for I in range length S. So basically how he is creating that is so he created two dictionary, count S, count T. For I in range length of S, count S के अंदर स्टोर करेंगे S का पहला एलिमेंट which is equals to 1 plus count S gets SI. What does this mean? Let's break down exactly what happens after that equal sign 1 plus count as. Okay, normally if you try to access a key that isn't a dictionary like count X, when X hasn't been in Python, crashes with key errors. The get key method prevents this, saying by look for the guess key if it's really okay. Step by step execution. Imagine if you are processing a string apple and you have reached the first P, count S get Python looks for P in the dictionary. Since it's the first time seeing it, it returns the default 0. It adds to the results. Now you have 1, count SI, it assigns 1 back to the key P. Oh, right. It's a good example. So basically, it's a safer way. To. Nice. I really like this solution. All right, I'm gonna copy this, but before that, this question was valid anagram. I'm gonna I'll search this question, and hopefully it's what happened. What happened? Oh yeah, don't click. भाई मैंने क्यों हटा दिया यार? I need to submit. It's saying it's logged. Subscribe to unlock feature. Oh मेरे गुरु. Wow. I hope I'm able to solve this. Solution. भाई मेरा प्रीमियम तो नहीं है ना भाई, ये सबमिट क्यों हो गया? सबमिट हुआ कि नहीं? ओके सबमिट हो गया, कुछ तो आया होगा यहाँ पे। नाउ लेट्स मूव टू द नेक्स्ट क्वेश्चन। Okay, replace elements with greatest element on the right sides. You are given an array, replace. Okay, I'll just move it here. Okay, you are given an array. Replace every element in that array with the greatest element among the element to its rights and replace the last element with -1. For example, this. So basically, they are saying that इस जो भी है उसको डिसेंडिंग ऑर्डर में कर दो, यही कह रहे हैं बेसिकली, राइट? ग्रेटेस्ट एलिमेंट अमॉन्ग डिसेंडिंग ऑर्डर में कर दो. सो is there any Python function to sort the array in descending order? All right, so what I have to do is that arr dot sort dot reverse equal to true, reverse equal to 2. What they are saying, reverse equals to true, capital tree, and then arr dot append -1. Return. Now I know there could be error. What's the error? Okay, I have to. How can oh yeah, how can I okay. I guess I have to pause the stream for a minute and I'll be starting that. How can I pause the stream? Is it possible? Is it possible to pause the stream? Okay, I'm not sure if it's gonna start a new stream or an old one, but for some reason it got frozen. Let me just open it again. Display capture. Okay. Let me just quickly check. Is it possible to pause the stream? I'm not sure if it's gonna start a new stream or an old one, but for some reason it got frozen. Let me just open it again. All right, dosto, it's working, and we have already covered, I guess, 30 minutes. So I'm just gonna start a clock again for 30 minutes, just to finish. Let's see how much we can do, and let's continue. The good thing which I understand that I can pause my stream as well, but it will still continue from there. But yeah, obviously I do not want to waste your time, and obviously nobody's watching at this point of time as well. So yeah, of course I was just studying this thing, and he got, okay, so basically this is what I thought. Gemini Go, this is what I thought. To implement. Tell me what is the issue. I'll keep it here in front. Okay, in your replace element code, there's two main issues. One is a logical flaw in the problem is solved, and the other user is a Python syntax error. The logical issue is sorting versus greatest on right. The problem requires you to replace each element with the greatest element strictly to its right. Your approach, by using reverse, you are finding the greatest elements in the entire array. Once you sort the array, you lose the original order. You no longer tell which element was originally to the right for another. For example, 2 4 5 3 1 2. The element to the right of 4 is 5. If you sort this, it might end up and it might up and the end. So basically my logic was that if all the greatest elements are gonna be on right, and if I understood the problem correctly, then the greatest element will always be on the right. That is, if I sort it in a descending order where the biggest element is on the first place, then it's satisfying the condition, right? Correct, if my understanding is correct or not. I see where you had it. You are thinking that if the array is sorted in descending order, the largest number move to the front, which seems like you satisfy the greatest element conditions. However, your understanding is not quite correct for the specific problems. Where is the right side rule? The problem doesn't just want the array to contain the large numbers. It requires that each specific position I will be replaced by the greatest number that was originally to the right of that position. So when you start the array, you move the number around. This breaks the original in timeline. Okay. And index I, at index I, value to the greatest element of it is right is 5. Right, the greatest element to this right is 5 at index 2. Okay. But why your sorted output is not having 2 5s in it, and why correct output is having 5? Like the original value, the original array should be having 5s, right? भाई ये क्या unshund logic बता रहा है? Let's go to solution and
Let's solve LeetCode 1299 and replace elements with the greatest element on the right side. So we're given an array, and we want to take each element in the array, for example 17, and replace it with the greatest element on the right side of it. So we scan through 18, 5, 4, 6, and 1. The greatest one is 18, so we can replace 17 with 18. the last element, 1, doesn't have any values that come after it, and the problem wants us to replace it with a negative 1. So basically what I do is just consider that there's an imaginary negative 1 over here that's not a part of the array, but we're just going to replace 1 with this negative 1. Now, if you don't know how to solve the problem, the first thing you want to do is draw a picture. This is going to make it a lot easier for you to visualize it and notice patterns. So once you've drawn the picture, choose the easiest way to solve the problem first. So we already kind of did that. So to replace 17, we're going to look at every element that comes after it. So each of the 5 elements, and we're going to take the maximum of these 5 elements. And we see that 18 is the max, so we replace 17 with 18. We can repeat this process. So for 18, we look at the last 4 elements. We see that the max is 6, so we can replace 18 with 6. To replace 5, we look at the last 3 elements. Again, the max is 6, so we replace 5 with 6. To replace 4, we only look at the last 2 elements. Again, the max is 6. To replace 6, we only have to look at the last element, which is 1, so we can replace 6 with 1. And of course, 1 is going to be replaced with negative 1. Once you draw it out, it's pretty easy to recognize the repeated work that we're doing. Because of the repeated work, this solution runs in O of n squared time. It's also obvious that since we're doing a lot of repeated work, that there is a better solution. So let's try to analyze it to come up with a pattern that we can use to make it more efficient. So the first thing that I notice is that the new value in position 0 is equal to the maximum of each value that comes after it. So in the array from position 1 to position 5. To get the new value in position 1, we did something very similar. We scanned through each of the last 4 elements. So we took the max of the array from position 2 to position 5. So this makes it even easier to recognize the repeated work that we're doing. We're taking the max in the array from 1 to 5, and then we're doing the max again from 2 to 5. Wouldn't it be easier for us if we took the max from 2 to 5 first, and then stored that value, and then to get the max, or to get the new value in position 0, all we have to do is take that stored value and compare it with the original value in the array in position 1. Let me draw it out to make it even easier. So the thing to notice is that these 2 equations that we wrote to get the new value in position 0, they're both equivalent. But in the original value over here, we have to get the maximum of 5 different values. Over here, in the new one we wrote, we only have to compare 2 values to get the maximum. This cuts down on all the repeated work. So the hint here is that to get the new value in position 0, we have to first get the new value in position 1. And to get the new value in position 1, we have to get the new value in position 2 first. So this problem leads us to iterate through the array in reverse order to cut down on the repeated work. So we're going to start at the end of the array and then compute the new values in reverse order. Of course, the new value in the last position is simply going to be negative 1, because that's like our base case. Okay, so let's go through it in reverse order. So our max value initially up until this point, before we've even gone through the array, is just negative 1, right? That's our base case. So we're going to replace 1 with negative 1. Now we want to recompute the maximum, right? And we only have to look at 2 values to do it. We only have to look at positive 1 and negative 1. So our recomputing the max up until this point is going to be positive 1. So we can replace 6 with positive 1. Now we're going to recompute the maximum again, and all we have to do is look at 6 and 1. 6 is greater, so 6 is our new maximum. We can replace 4 with 6. Now we're going to just keep repeating this, right? So our new maximum up until this point is 6, because 6 is greater than 4. We just have to look at 2 elements. So we can replace 5 with 6. Now we're going to do it again. The max up until this point, we just looked at 5 and 6. 6 is greater, let's replace 18 with 6. Now let's recompute the max up until this point. 18 and 6, 18 is greater. So we can replace 17 with 18. Now we can recompute the max here, right, between 17 and 18, but there's no point to do it because there's no more elements that we have to replace. So now we've done it. All we had to do was go in reverse order, which cut down on all the repeated work. We didn't need to use any extra memory, and therefore the solution, the runtime, is just O of n. Now let's write the code. So before I write the code, I like to write a few comments to remind myself what to do. So we remember that the initial max can be set to negative 1, right? Because that's the last value, that's what the last value will be replaced with. And the reason this works is because it'll eliminate some edge cases for us, and we know that every value in the array is positive, so we won't have to run into any extra edge cases. The next thing we want to remember is reverse iteration. We're going to start at the end.
This is crazy. This is tough. This is tough. मेरे को क्वेश्चन ही समझ में नहीं आया भाई ये मेरे को लगा like what I thought is that I have to replace everything. The greatest is gonna be the first one and I have to bring it to the first. Anyhow, I'll stop at this point of time and I'll continue tomorrow. I'll just continue tomorrow from this question. All right, guys. Thanks.